Hello children, happy Monday morning. Today I am your physics tutor, Mrs. Vijayalakshmi Ramakrishnan. Today I am going to go through the chapters ray optics and wave optics. Before that, let us quickly go through how to access this Clay6 page. First of all, go to clay6.com. Click on that. This is our home page. Go to the practice session. You can select the package, NEET Premium. There you can see the revision notes. Click on that. Revision notes is basically the concepts and important formulae for all the three subjects, physics, chemistry, and biology, tailor-made for NEET exams. We have essenced everything. We have it is more of an essence of all the three subjects, chapter-wise, physics, chemistry, and biology. Chapter-wise, right, for both grade 11 and grade 12. You can go through this. And then once you are thorough with all the concepts and ready for the test, you can as well take the tests and practice it more than one times. Now, quickly let us go through this topic, electromagnetic waves we saw. Today we are going to see ray optics and optical instruments and wave optics. Both, I am combining both as optics. Now, coming to, because it is more of both of them are connected together, I thought I need not give a break for both the lessons. Both of them are conceptually the same. So once you are thorough with the concepts in the first lesson, that can be continued for the second lesson also. So I thought I could combine both the two chapters as one and name it as optics. So ray optics and optical instruments, the first chapter. The laws of reflection, you know, angle I is equal to angle R. Now, ray optics deals with the waves which are the rays. It is more of a geometrical form, you can say. It is more than, instead of a wave form, it is more than a rectilinear propagation of light. You can say that light travels in straight lines. So that form of optics, the optics which deals with this rectilinear propagation, it is called as the ray optics. And based on this, the optical instruments like telescopes, microscopes, all these are made. So we are going to quickly look into this lesson. What are the important formulae you have to know and the concepts you have to know. So first law is angle I is equal to angle R, where I is angle of incidence and R is the angle of reflection. Snell's law, mu is equal to sin I by sin R, which is equal to velocity of light in vacuum by velocity of light in medium. The diffractive index of a medium A with respect to B is given by A mu B. Mu is the refractive index, which is equal to mu B by mu A. And A mu B, that is mu B A mu B is mu B by mu A, and B mu A is equal to the reciprocal of this, that is 1 by B mu A, or you can put it as mu A by mu. So when you multiply this, you'll get it as 1. So if it is now going to be more than 2 medium, then you can put it as, when it comes back to the same medium, it is the refractive index is now going to be the same. The emergent ray will have the refractive index is now going to be 1. So mu is equal to, when we consider the total internal reflection, there you say, or in other words, a refraction, not instead of total internal reflection, we can see the refraction part. So refraction part, you know, by Snell's law, sin I by sin R is equal to mu, we saw that. So mu is equal to the real depth by the apparent depth. Like say, when you place a coin in a bucket of water, you feel as if the actual depth is not shown. Instead, it is as if the coin is now going to be very nearer than the actual distance. So that distance which we see is called as the apparent depth. So real depth by apparent depth will give you the refractive index of the medium. So critical angle IC, sin IC is equal to 1 by mu, where I is called as the IC is the critical angle. So once it reaches the ray which is passing through the medium, once it is now going to be more than the angle of incidence is more than the critical angle, then it undergoes total internal reflection. Now, what are the conditions for total internal reflection? Refraction takes place from the denser medium to a rarer medium, and the angle of incidence must be greater than the critical angle for the pair of medium contact. So these are the 2 points you'll have to know for internal reflection to total internal reflection to happen. Next coming to the lens and mirrors, the spherical mirrors. The mirror formula 1 by f is equal to 1 by v plus 1 by u, where u is the object distance, v is the image distance, and f is the focal length. For refraction through spherical surface, that is from rarer medium to a denser medium, mu1 by minus mu plus mu2 by v is equal to mu2 minus mu1 by r. So mu1 is the refractive index of the first medium, u2 is going to be the refractive index of the second medium, u is the object distance, v is the image distance, and r is the radius of curvature. Now applying the sign conventions, you can put the symbol according to it, because according to the sign conventions, whatever is now going to be the left side, it will take the negative symbol, and whatever is now going to be placed on the right side of the lens, it is now going to have the positive symbol. So same way, when it is going to be in the upward direction, say the object which is formed in the upward direction of the vertically in the upward direction, then you say, for example, erectomid, then it is going to take a positive sign. And when it is now going to be the downward direction, like say the inverted image, then you say it is going to be negative. It will take a negative sign. Next, coming to the lens formula, 1 by v minus 1 by u is equal to 1 by f, where u, v, and f has the usual meaning. The lens maker's formula, this is very, very important, children, for both concave and convex lenses. 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. For combination of lenses, 1 by f is equal to, you can just, it is going to be the reciprocal of all these focal lengths. So 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3 and so on till 1 by fn. Power of a lens P is given by 1 by f, where f is the focal length, or that so meters, or if it is now going to be 100 by, you can, if you want to convert it to meters, then it is 100 by f centimeters or 100 by f diopters. So the unit for power is diopter. Power of combination of lenses, you can just simply add everything, P1 plus P2 plus P3 and so on till Pn. So the refractive index, so remember, power is nothing but the reciprocal of the focal length. Refractive index of a prism whose angle is mu is equal to sine of A plus delta, children, A plus delta by 2, where delta is the angle of deviation, and by sine of A by 2, where A is the prism angle. So remember, refractive index mu is given by sine of A plus delta by 2 by sine of A by 2. So make that change. In refraction through a prism, A plus delta is equal to I1 plus I2. Now, you know, prism has two refracting surfaces. So the A is now going to be the angle of the prism, and delta is now going to be the minimum angle of minimum deviation, and I1, I2 are the two angle of incidences on the two refracting surfaces. And R1 and R2 is now going to be the refracting angles. I1 and I2 are the refractive, I1 and I2 are the angle of incidences on the two surfaces, and R1 and R2 are the refractive angles, which is equal to A. So R1 plus R2 is equal to A. If delta is equal to delta M, that is angle of minimum deviation, then you say then I1 is equal to I2 and R1 is R2. So at minimum deviation, you can say I1 is equal to I2 and R1 is equal to R2. So note all these formulae, it's very, very important. We'll be making use of these in the problems to come. Magnifying power of a simple microscope, M is equal to 1 plus D by F, where D is the least distance of distinction and F is the focal length and M is the magnification. Magnifying power of the compound microscope, M is equal to L by F0 into 1 by D by FO. FO is the focal length of the objective. L is the length of the microscope, and D is the least distance of distinction. Say it is 25 centimeters. Magnifying power of an astronomical telescope, the normal adjustment M is equal to minus FO by FE. When the image is formed at least distance of distinction, then M is equal to minus FO by FE times 1 plus FE by D, where FO is the focal length of the objective. You have two lenses, the astronomical telescope and compound microscope, you know that. So it is the lens which is now going to be near the eye is called as the eyepiece, and which the lens which is now going to be near the object is called as the objective. So the focal length of the objective lens is FO and the focal length of the eyepiece lens is FE. The dissolving power of telescope is equal to D by 1.22 lambda. Angular limit of resolution for telescope d theta is equal to 1.22 lambda by D. And these are some of the things which can know. Lateral shift is given by I sine of I minus R by cos R. And normal shift T is equal to T times 1 minus 1 by K mu B, where T is the time taken. And A mu B is the refractive index of B with respect to A. And then, A with respect to B. Displacement F is equal to A squared minus D squared by 4. So these are the important formulae you'll have to know. Miscellaneous, you can know this. Length of astronomical telescope tube for normal adjustments L is equal to FO plus FE. So remember we saw the formula here, L. Yeah, see here L, magnifying power of a compound microscope. In that place of L, you can put it as FO plus FE. Having known FO and FE, you can easily substitute that and add up and put it in the place of L. Same way, length of the terrestrial telescope is given by FO plus 4F plus FE. So remember these formula. Next is wave optics. So these two lessons are very, very important, children. They have a weightage of 4%. So you can expect at least 2 questions from this particular lesson. So it is a very important lesson you have to know. So when we were talking about the 11th standard portions, we saw that kinematics and gravitation, and we were talking about the different topics which were equally important, right? Like when we come down to 12th standard, this lesson is going to be very, very important. So these 2 lessons. So optics as a whole, you can take the 2 lessons as one and then make a note of all the formula and the formulae and the concepts behind it, and then make yourself thorough with these, because these 2 lessons are very, very important. I'm insisting again and again. So make use of the NEET notes. Intensity at any point where phase difference is phi is equal to I equals K times I1 plus I2 plus 2 root of I1 I2 cos phi. Position of the bright fringe is X is equal to N D lambda by D, where N can take values 1, 2, 3. Position of the dark fringe, X is equal to 2N minus 1 into D lambda by 2D, into, where N is equal to 1, 2, 3. Now, D is the distance between the screen and the source, and small d is the distance between 2 slits. And lambda is the wavelength. Fringe with beta is given by lambda d by d. Distance between the source, small d, is given as d, and the distance between the screen and the source is given as capital D. Make a note of it. Condition for fraction. Condition for like diffraction conditions for diffraction. That is, you'll have to know minima. Whenever you need a minimum diffraction, A sin theta is equal to n lambda, where n is equal to 1, 2, 3. And maxima is A sin theta is equal to 2n plus 1 lambda by 2, where n takes values 1, 2, 3. Width of the central maximum, 2x is equal to 2d lambda by d, which is equal to 2f lambda by d. You can say it as 2f lambda by d also. It's enough you remember 2d lambda by d, that is enough. So angular width of the central maxima is given by 2 theta is equal to 2 lambda by a. Brewster's law, this is very, very important. You can definitely expect one question related to Brewster's law. Mu is equal to tan of IP. Fresnel distance ZF is equal to a squared by lambda. When the apparatus is immersed in a transparent medium of a refractive index, the fringe width is given by beta dash is equal to beta by mu, which is equal to lambda d by mu d, where mu is going to be the refractive index of the medium. Lambda is the wavelength. Angular fringe width theta is equal to beta by d, which is equal to lambda by d. So having known all the values, you can actually calculate the angular fringe width. And this is, if it is not very important, but still you can know it. Relation between slit widths, intensity and amplitude of waves. W1 by W2 is equal to A squared by B squared is equal to I1 by I2. So I1 and I2 are the intensities. W1 and A squared and B squared are the amplitude of waves, and W1 and W2 are the slit widths. So having known all these formulae, and of course, having known all the formulae, make yourself thorough with everything, and then now we can go to the test part. So again, we have made tests for all the subjects, physics, chemistry, biology, and the NEET full tests also. So you can take any test any number of times. Once you are thorough with the concepts, you can go to the NEET full tests, where you can take that also any number of times until otherwise you are happy with the results and your concepts. Okay. Now we can that we have done revision tests for all the chapters. Now we'll go to optics. Now here you can see the different colors. The blue bubble says you have not taken up the test. The green bubble says you have already taken the test, and the red bubble is a random test. You can also see the yellow bubble in the previous things. That means it is an incomplete test. So you can, once you are thorough with the concepts, you can complete it again. Even if you have taken the test once, you can take it any number of times until or otherwise you are going to be happy with the results. Click on that. Click on take test. Go to test. Now it appears. The first question says, a ray of light is incident at 30 degrees on the plane mirror. What is the angle between the mirror and the refracted ray? All right, children, this is quite easy. Let us draw the diagram and see. So this is the plane, and that is a normal. Now this is going to be angle of incidence, and this is now going to be angle of refraction. So he says angle of light is incident at 30 degrees. What will be the angle between the mirror and the refracted rays? You know, sin I is equal to R for a reflected ray. So 30 degrees is the correct option. That, go to the next. Two mirrors are inclined to each other in such a way that the ray of light moving parallel to one mirror comes out parallel to the other mirrors after two reflections. The angle between the two mirrors is 1. Yeah. Let's quickly draw the diagram for this. So, two mirrors are now going to be parallel to each other. So, let us take this angle to be theta. So, obviously, this will also be theta. because they are parallel. So light is now going to be, sorry, light is coming actually in this direction. So it gets reflected here and then goes in this direction. Now let us take this as mirror 1 and this as mirror 2. Now this angle is theta. Obviously, you know this angle is also theta. Let me mark this as CAB and CD. So it is now given, let us take the angle CDB to be equal to theta. Since mirror, the AB is parallel to this mirror, then it is now going to be angle ABM2 is also equal to theta because they are corresponding angles. Then we can also say, since if I draw the normal here, now you know this is angle of incidence. So this will be angle of, sorry, this is angle of incidence, this is the angle of reflection. So angle of incidence is equal to angle of reflection. So the other angle also will be equal to theta. That is angle CBD is also equal to theta. Now this is theta, angle M2C, let me mark this as E is also equal to theta because these both are corresponding angles. So again, this is now going to be, when I draw the normal here, again, this is now going to be I and this is going to be R. Now I is equal to R. So this angle will be again theta. So that is angle DCB is also equal to theta. Now consider the triangle CDB. You can see theta plus theta plus theta is equal to 180 degrees, or 3 theta is equal to 180 degrees, or theta is equal to 60 degrees. So the angle between them is 60 degrees. Let's see which option is correct. 60 degrees. D option is correct. Save that, go to the next. A man is walking towards a plane mirror at a speed of 4 kilometers per hour. With what is the speed with which he is approaching his image? Look, read the question properly. He is walking towards a mirror at the speed of 4 kilometers per hour. What is the speed with which he is approaching the mirror? So the man is moving towards a plane mirror at a speed of 4 kilometers per hour. So his image will also move at the same speed. So it will be moving at the same speed of 4 kilometers per hour. But it will be in the negative direction because it's now going to be a virtual image. It is now going to be the relative speed of, therefore, the relative speed of the mirror with respect to the image is now going to be 4 minus of minus 4 because if the source is now going to be the plus 4, that is in the forward direction, whereas the image is now going to be the same 4, the magnitude is going to be 4, but in the opposite direction, so minus 4. So the difference between the two distances is now going to be 4 minus of minus 4, which is equal to 8 kilometers per hour. So a ray of light is incident at an angle of 20 degrees to the normal. What is the deviation caused due to reflection? All right, let us quickly solve that. Let us draw the diagram for this first. Let this be normal. So the light is incident like this. And this is now going to be the refracted ray. If this is 20 degrees, this is also going to be 20 degrees. Let this be A. Had it not gone undergone reflection, then it would come this along this line AC. So the original path of light should have been AC if it had not undergone reflection. So the reflected ray is now deviated from its original path by, let us say, delta. Okay, it is now going to be. So the whole angle is now going to be 180. So I can put it as 180 minus 20 plus 2 delta. Sorry, 20 plus 20. I'm sorry, 20 plus 20 because angle of incidence is equal to the angle of reflection. So that is equal to 20 by 20, which is equal to 140 degrees. Let's see which option is correct. 140 degrees. Yes. Click that. Go to the next. A ray of light is reflected by two plane mirror mutually perpendicular to each other. What is the deviation of reflected ray from the incident ray? All right. This is quite easy, even though, let us say, two mirrors are perpendicular to each other. So obviously, if I say this is now going to be the angle of incidence, AB, this would directly go there and then again get reflected back like this along CD. Let me draw the normals between the, so obviously the normals of the two mirrors or the two rays, if I draw like this, let me mark this as N1 and this as N2. You can see that they are now going to be perpendicular to each other. Let us say this angle is theta. So now you can see that angle ABC plus angle BCD. Angle BCD. That will be equal to, so this is going to be theta, this will also be 2 theta, right? So 2 theta, and you know this is now going to be 90 degrees. So plus 2 times, so that angle will be 2 times 90 minus theta. Because again this angle and this angle will be the same. So this will be 90 minus theta and this will all be 90 minus theta. So it will be 2 times 90 minus theta. So because this is 90 already, so this angle would be 90 minus theta, right? Same way this will also be 90 minus theta because this is angle of incidence and this is angle of reflection. So they are equal. So it will become, so when I add these two angles, it is now going to be ABC plus BCD is now going to be 2 theta plus 2 times 90 minus theta. That is equal to 180 degrees because they are now, you know, AB and CD are parallel to each other. So they are co-interior angles. You know, co-interior angles, the angles on the same side of the transversal are supplementary. So that is now going to be 180 degrees. So rays after reflection from two mutually perpendicular becomes anti-parallel. You can see they go anti-parallel in the sense they are now going to be, the magnitude will be the same, but it will be the opposite direction. They are going to be parallel, but it will be in the opposite direction. So let's see which option is correct. Option C, 180 degrees is correct. So go to the next. Which one of the following statement is true? Concave mirrors can give diminished virtual image. Given a point source of light, a convex mirror can produce parallel beam of light. The image formed by plane mirror is real. The image formed by the plane mirror can be photographed. All right. Which is true? Which one of the following is true? So we can see concave mirror can give diminished virtual image. No, that is not true. Given a point source of light, a convex mirror can produce parallel beam of light. No, that is also not true. Image formed by a plane mirror is real. No, that is also not true. You know, the image formed by a plane mirror is virtual. So D should be correct. The image formed by a plane mirror can be photographed. Yes, that is true. So D is correct. Okay. Coming to the 7th one. A concave mirror of focal length f in air is immersed in water. U is equal to 4 by 3, whose refractive index is given by mu is equal to 4 by 3. The focal length of the mirror in the water will be what? Now, the focal length, whether it is now going to be irrespective of whether it's concave or convex, they will not depend upon the refractive index of the surrounding medium. So, therefore, the focal length will be the same as that of the concave mirror. So, option B should be correct. So, remember this point. Focal length does not depend upon the refractive indexes, whether it is going to be concave or convex. Now coming to the eighth one. An object of length 3 centimeters is placed on a principal axis of concave mirror of focal length f at a distance of 4f. The length of the image will be what? Okay. Let's quickly solve this. Now you all know that m is equal to I by O. That is image distance by object distance, which is nothing but f by f minus u, where f is the focal length and u is the object distance. So from this we get that I is equal to, so object distance is given as I, so you can take it as I is equal, I by 3 is equal to minus f, since it is now going to be a concave lens, we are taking it as a negative. So minus f minus u. So therefore I by 3 is equal to u. This is u. So which is equal to, he says it is 4 times. So that would be minus f by minus f minus or minus 4f. Okay? So that would give you minus f by minus of minus becomes plus 4f, minus f is now going to be 3f. So I by 3 is equal to minus f by 3f, f gets cancelled. So this says that I is equal to minus 1. So let's see which is correct. Minus 1 centimeter. Save that, go to the next. Image formed by a concave mirror is 3 times the object, focal mirror, object 3 times object. Focal length of the mirror is 6 centimeters, then the object distance is 1. He has given you that the image is 3 times the object. All right. Image is 3 times the object, so the magnification is now can be taken as plus or minus 3. And f is given as minus 6 centimeters. So we saw that magnification is nothing but f by f minus u. Now we have to consider the two cases, that is plus 3 and minus 3. Minus 3 if it is going to be for a real image, and plus 3 if it is now going to be a virtual image. Now let us consider for minus 3 if it is going to be a virtual image. So that gives you minus 6 by minus 6 minus u. So that would give you, when you simplify, cross multiply that, that gives you minus 18, plus 18 plus 3u is equal to minus 6, or 3u is equal to, that gives you minus 24, or u is equal to minus 8 centimeters. So this is 1. What is the case if it is now going to be a virtual image? Plus 3 is equal to, then it is now going to be minus 6 minus u, then it becomes minus 18 minus 3u is equal to minus 6, or this implies minus 3u is equal to 12, or therefore u is equal to minus 4 centimeters. Let's see which option is correct. So option A, minus 4 centimeters is correct. So let's take that. You might be confused. 8 centimeters is also there, but we got minus 8 and minus 4. So only can click option A. Now coming to the 10th one. Wavelength of a color of light for air is 6000 degrees angstrom, and in water the wavelength is 4500 degrees angstrom. What is the speed of light in water? All right. This is easy. Velocity into wavelength is always a constant. Remember that. So v1 by v2 is equal to lambda 1 by lambda. So or v2 by It is now going to be light, right? So velocity of light can be taken as v2 by v1. So v2 by 3 into 10 to the power of 8 is equal to, we can take this 4,500 divided by 6,000. The wavelengths are given. So when you simplify, 2 it gets cancelled. So 5 9s are 45, 5 12s are 3 3s are 9, 3 4s are 12. So V2 is now going to be equal to 3 into 3 10 to the power of 8 divided by 4. When you simplify that, that gives you 2.25 into 10 to the power of 8 meters per second. So let's see which option is correct. 2.24, option B is correct. Save that, go to the next. A light wave has wavelength 6,000 degrees angstrom in vacuum. The wavelength of this light when it passes through a certain glass of refractive index mu is equal to 1.5 is what? Let's quickly solve that. Same way, you can also say mu1 by mu2 is equal to lambda 1 by lambda, where mu1 is going to be the refractive index of air and mu2 is going to be the refractive index of glass. Lambda 1 is the wavelength in air and lambda 2 is the wavelength in glass. So having known all the values, just substitute. You know, refractive index in air is now going to be 1 and this is given as 1.5 is equal to lambda 2 divided by 6,000. So therefore, lambda 2 is equal to 6,000 divided by 1.5. So that gives you 4,000 degrees angstrom. So let's see which option is correct. Option A is correct. Click that, go to the next. Light travels through a glass of refractive index mu is equal to 1.5 of thickness 4 millimeters. What is the time taken for the light to cross it? All right. Optical distance in a medium of refractive index mu and thickness T is mu x. Optical distance. Optical distance is equal to mu x. Where we take, so time is going to be equal to distance by speed, that is mu x by c, where c is the velocity of light. Having known all the values, we can just quickly substitute. 1.5 into x is given as 4 into 10 to the power of minus 3 divided by c is 3 into 10 to the power of 8, which is equal to, when you simplify this, it gives you 2 into 10 to the power of 11 seconds. Let's see which option is correct. Yeah, option A is correct. Save that, go to the next. A ray of light is incident on a rectangular glass block at 45 degrees on glass-air interface. The refractive index of glass is √2, then the ray will emerge back into the air without deviation, will be reflected back into the glass without emerging into the air, will emerge into the air with an angle of refraction equal to 90 degrees, will neither be reflected nor refracted but will be absorbed. All right, let us quickly calculate this and find out the result. Now it's given that ug is equal to √2. A mu g, in the sense it is now going to be with respect to glass, it is now going to be √2. Air with respect to glass is now going to be √2. So therefore, g mu A will be equal to the reciprocal of this, 1 by √2. So angle of incidence from glass to air is given as 45 degrees. All right. So 1 by √2 is equal to sine 45. You know sine I by sine r, is it not? So angle of incidence is sine 45 by sine r. That is, but sine 45, you know, it is 1 by root 2. So that is equal to 1 by root 2 is equal to 1 by root 2 divided by sine r. Or from this we get sine r is equal to root 2 and root 2 will get cancelled. So you get it as 1. When is sine 1? When r is going to be equal to 90 degrees. So this says r is equal to 90 degrees. Let's see which option is correct. C is correct. All right. The 14th one. A ray of light is incident from air on a surface of medium at an angle of 60 degrees. The angle of refraction in the medium is 30 degrees. What will be the velocity of light in the medium? Let's quickly calculate. Now, you know, mu is equal to velocity of light in air by velocity of light in the medium. Which is also equal to sin I by sin r. So we can say C by V is equal to sin I by sin r, which is given as I is given as 60. So this will be 90 minus 60, which is 30. So sin 60 divided by sin 30. All right. So therefore, from this we get, you know, C is the velocity of light. So V is equal to C into sin 30 by sin 60. Now, having known all the values, we can now substitute. So that would give you 3 into 10 to the power of 8, which is the velocity of light, into sin 30 is half and sin 60 is root 3 by 2. So simplify that. We can see that half and half will get cancelled. So 3 root 3, root 3, root 3, we can split 3 as root 3 times root 3. So you'll be left only with root 3 into 10 to the power of 8. You know, the value of root 3 is 1.73 into 10 to the power of 8 meters. So let's see. 1.6. So you get 1.73 in 10 to the power of 8 meters per second. Option D is correct. Click that. Go to the next. A glass slab of refractive index 1.5 and thickness 3 centimeters is placed on a black dot on a piece of paper. A person looks at the mark from a height of 8 centimeters above it. The dot will appear at a distance of 1. This is very easy, children. We all know that apparent depth is equal to real depth by mu. So we can write it as apparent depth is equal to real depth by mu. So the real depth is given as 3 and the mu is given as 1.5. So which is equal to 2 centimeters, you know. So the person sees the dot at a distance of 8 plus 2, which is equal to 10 centimeters. So the distance from his eyes to the surface is going to be 8. And from there, this distance is going to be 2. So he is now going to see at a distance of 2 centimeters. Let's see which option is correct. 10 centimeters, yes. So option D is correct. So we have completed everything. Save that. End the test. Say yes. Now the results are loading. Let's see if there is anything wrong. Yeah, it says one answer is incorrect. Let's see. First question. A ray of light is incident at 30 degrees on the mirror. What is the angle between the mirror and the reflected ray? So I said it was 30, but this. Let us see the option. It's the correct answer says it's 60. So the reflected ray and the thing will be, so it is 30. I is equal to R, 30. So this should be the whole angle is now going, now NOB is 90 degrees. So this should have been 90 minus 30, which is equal to 60 degrees. So B is the correct answer. All right. So close that. So other answers, everything was correct. So if all your answers were correct, then it will be denoted by the green color. If your answer is wrong, then it is now going to be a red color. Unanswered, if you would have forgotten to save the options, then that would have shown as an yellow color. So you can as well check your answers, the wrong answers, by clicking on it, and you take the, you can also know the explanation part also. Likewise, you can make thorough of all the concepts again and again, and you can take the test any number of times. So since one question went wrong, now you can as well, until you are going to get the whole test, all the answers to be correct, you can go on repeating the tests, because there's nothing wrong in repeating, because we are now going to make sure of all the formulae which we are going to use again and again, so that when you go to the next test, it is going to be pretty easier. So likewise, we have, the questions might be different in the, it will be different in the different tests, right? So having known all the formulae, maybe you will be doing the second test in a very short time. So time management is very, very important, children, especially the exam point of view. You have to crack the test at a very, very fast rate. So for that, the concepts and the formulae should be at the tip of your fingers. So only then you can manage the time easily, especially for physics. So make yourself thorough with the concepts, make use of the NEET revision notes which we have given, purchase it, and then make use of it, and then you can as well get very good marks. So with this, we have come to an end. Do you have any questions to be asked today?